We would like to welcome our chief guest, Dr. R.K. Maheshwari ji, with us, who is present here. We are very humbled by his presence, and we would like to take blessings from Dr. Rajesh Kumar Maheshwari ji that please allow us and give your blessings to start this digital seminar.
Please start, please.
Thank you so much, sir. So, those who are new to us and the society, I would like to share few details about the society. This is an educational society in the pharmaceutical sector, which are driven by a shared dedication to the education, research, innovation that contributes to the all-round growth of the pharmaceutical industry, including teachers, students, industrialists, scientists, researchers, and many more. Pesots is committed to a very strong synergy between the pharmacy, teachers, student, through which it promotes educational learning, research opportunities among the teachers, student, professional, and practitioners of pharmacy by bringing awareness and also maintaining the ethics of pharmacy profession. It learns to serve humanity. The one of the aim of the society is to build a platform on which pharmacy students and teachers can both interaction with the coordination that will help to grow the pharmaceutical education and research. We can help the humanity in the respect of healthcare and in the broad field of our pharmaceutical science. Those who want to know more about us and the society can surely join us, and feel free to contact us and visit us on www.pesots.in to become a part of a future of pharmacy. And with now joining us, our chief guest and eminent speaker, Dr. Rajesh Kumar Maheshwari ji, Professor from Department of Pharmacy, SGSIT Indore. I extend my heartfelt gratitude to our esteemed guest, sir, for giving us your precious time and allowing us to share your knowledge with our society members, students, and teachers. We are very excited to have you here, sir, with us. सर का नाम तो बहुत लोग जानते ही हैं पहले से, बट फिर भी मैं चाहूंगा जो नए हमारे अपकमिंग फार्मासिस्ट हैं, फ्यूचर फार्मासिस्ट हमारे स्टूडेंट्स हैं, उनको सर के बारे में कुछ मैं बताना चाहूंगा. ही इज अ वेरी डेडिकेटेड प्रोफेशनल. He has been working for more than 30 years in this field. He is truly dedicated and he has inspired many people over the years. And he has more than 180 national and international research and review papers. And till now, to date, he has delivered more than 300 lectures globally, including 15 international lectures. एंड मैं सर के साथ कांटेक्ट में रहा हूँ, तो सर के थ्रू मुझे पता लगा है कि जो हमारा आज जो सेमिनार होने वाला है इसमें सर लेक्चर दे रहे हैं. दिस इज द 327th लेक्चर फॉर द सर. ही इज ट्रूली अ ग्रेट विजनरी इन दिस फील्ड. His expertise and insight will undoubtedly enrich an understanding of our vision and help us to push the boundary of our knowledge in this sector. Sir, please guide us with your knowledge and ignite the flames of the progress, and together we build a brighter future for tomorrow in the pharmaceutical sector. Sir, please, over to you.
Okay. Good morning to all of you. Firstly, I would like to thank Dr. Gautam and Dr. Himanshu Sharma ji, and of course, all the members of the society, because of whose effort I am here with you to share, to discuss the new research ideas, particularly in the field of solubilization. Firstly, let me tell you what you shall get in my lecture. The new things, very new things you will get in my lecture is that we can utilize the solubilizing power of safe and economic solids to replace harmful organic solvents. Why organic solvents should be replaced? The reason is that they are very harmful for human beings. And in my lecture, you will find their drawbacks, and of course, they are costly also, organic solvents. So, without organic solvent, just by use of solubilizing power of solids, we can minimize the use of harmful organic solvents which are volatile, and the vapors of such solvents they are inhaled by the human being whosoever is involved in such operations like analysis, formulation, synthesis, extraction, etc. So this is the new thing you will find in my lecture. So now I am starting my PowerPoint presentation directly, and I will explain you that how the solubilization by use of solids is very important, economic as well as it minimize the use of harmful organic solvents. Okay, so today's topic is more or less same. Solubilizing properties of solids, cell replace harmful organic solvents. During my lecture, so many doubts may come to your mind. So please note down your questions. At the end of the lecture, we will have question answer session. So your doubts will be cleared after the lecture is over. Now, where the organic solvents are involved? Various organic solvents are employed in various analytical techniques like Hillier chromatography, HPTLC, HPLC, UV spectrophotometric analysis, titanometric analysis, etc. Also, organic solvents are involved in extraction of active constituents from herbal powders. Also, these organic solvents are involved in the synthesis of organic compounds. Also, in formulation of pharmaceutical dosage forms, in identification test of drugs, etc. Now, what are the drawbacks of organic solvents? Organic solvents have innumerous adverse effects caused by single exposure, like hepatitis, headache, drowsiness, nausea, irritation, etc. Single exposure means once when we perform some experiment with organic solvent, there may be headache, irritation, etc. So these are the reversible processes. They are not so injurious to your health. Okay, but long-term exposure causes serious effects such as neurological disorders, chronic renal failure, liver damage, neurosis, mutagenesis disorder, etc. What is this long-term exposure? When some persons they are involved, say for example in analysis. Suppose if human being is analytical chemist, so daily he has to carry out the estimations or assays of the drugs and all that. So many means he is exposed to the vapors of organic solvents so frequently and for long duration of time, months together or years together. So this thing is very harmful for the human being. So such, you may say, harmful effects are there that are vapors of organic solvent. Organic solvents are costly and their disposal requires a special treatment. Organic solvents themselves, they are costly. Also, their disposal after they are used from the industries, when they are thrown away from the companies, from the laboratories, when they are thrown in bulk, they should be given a particular treatment to make them safe before they are thrown away. So another cost involving factor. So anyway, organic solvents are costly as well as their disposal is costly. Now there are three classes of organic solvents. Class 1 organic solvent, benzene, very carcinogenic. It is carcinogenic. Carbon tetrachloride, very harmful for human being. Similarly, these aerosol propellants, they are also very harmful for human being. So these are like some examples of class 1 organic solvents which are very injurious to our health. Class 2 organic solvents commonly employed include acetonitrile, chloroform, toluene, methanol, pyridine, hexane, dimethylformamide, etc. These class 2 organic solvents are relatively somewhat safer than class 1 organic solvents. But then also they are very harmful for human beings. Class 3 organic solvents, they are safest among these three classes. Class 1, class 2, class 3. Class 3 organic solvents are safest, but then also they are also very harmful for human beings. Commonly employed class 3 organic solvents are acetic acid, acetone, ethanol, ethyl acetate, etc. Sometimes I will give some examples. When you are forced to use some organic solvent, and suppose because of the solubility problem you are supposed to use class 2 or class 1 organic solvent, you can potentiate the solvent power of class 3 organic solvent using solubilizing power of solids to act as class 2 or class 1 organic solvent so that you can minimize the harmfulness for the human being. So what I want to means I will go some two examples in my lecture. How can you potentiate the solvent power of a class 3 organic solvent to behave like a class 2 or class 1 organic solvent as far as the solubility problems they are concerned. Future role of solvent character of solids. Solubilizing power of solids shall minimize the use of powerful organic solvents in future. Class 3 organic solvents are relatively safer than class 2 and class 1 organic solvents. Of course, we can potentiate the solvent power of class 3 organic solvents by dissolving safe solids in them to replace class 2 and class 1 organic solvents. Let me again repeat. in my lecture you will find the solubilizing power of solids, which can minimize the use of harmful organic solvent. What happens in dissolution? Dissolution of a solute in a solvent involves hydrogen bonding and weak van der Waals forces between the molecules of solute and molecules of solvent. Say, for example, if you dissolve, say, for example, dextrose in water, you get a solution of dextrose in water. You dissolve mannitol in water, you get mannitol solution in water. Why? As a result of this dissolution takes place as a result of hydrogen bonding and weak van der Waals forces between the molecules of mannitol and molecules of water. If you are dissolving, say, for example, salicylic acid in ethanol, you are getting a solution as a result of hydrogen bonding and weak van der Waals forces between the molecules of salicylic acid and molecules of ethanol. So this happens, this is the general small mechanism of dissolution of a solute and a solvent. When there is limited bonding, weak van der Waals forces, then there is great solubility. Anyway, I will explain in my lecture. Now, mixed solvency concept. I have proposed in the year 2009, first time in the world. And there are two parameters of this mixed solvency concept. Number one parameter says that each and every substance, gas, liquid or solid, present in this universe has got solubilizing power. In other words, you may say each and every materials found in this world, they possess solubilizing power. But only thing will be, as you know that in case of liquid, the molecules are already in liquid state. So these liquid state molecules of liquid, they are involved in hydrogen bonding with one another forces. But for gases and solids, to act as solvent, the molecules of gases or molecules of solids should be in liquid state. Then only these molecules of gas or molecules of solids will be involved in hydrogen bonding and weak van der Waals forces with the molecules of solutes for their dissolution. These examples I will do in my lecture. Okay. Now, in other words, one more thing we can say whatever the molecules are present in this universe, all molecules possess solubilizing power. Once the molecules of a gas or molecules of solid come in liquid state, they may also be involved in hydrogen bonding and weak van der Waals forces with the molecules of solute for their dissolution. About solvent, whatever matter exists in liquid state at room temperature is known as solvent. For example, you know, water, ethanol, methanol, chloroform, acetone, etc., etc. Whatever the substances, they exist in liquid state, they all are known as solvent. But whatever the name of any solvent you take, that solvent possesses good solubilizing power for some solutes and bad solubilizing power for other solutes. This statement we have to remember to learn the remaining part of my lecture. What I am saying, liquids at room temperature, the substances that in liquid state, they all are known as solvent, but whatever the name of any solvent you take, that solvent possesses good solubilizing power for some solutes and bad solubilizing power for other solutes. For example, we see from the books that water is good solvent for 1/3. Or you can say that about 1/3 of the drugs they are water soluble, about 2/3 of the drugs they are water insoluble. This means water is good solvent for some drugs, water is bad solvent for other drugs. So whatever the name of any solvent you give, whether it is DMSO, DMF, chloroform, etc., they possess good solubilizing power for some solutes and bad solubilizing power for other solutes. Similarly, each liquid, let me read from this. Each liquid, the so-called solvent, possesses good solubilizing power for some solutes and bad solubilizing power for other solutes. Similarly, each matter, whether the matter is liquid, whether the matter is gas, whether the matter is solid, is known as solubilizer in mixed solvency concept. Each molecule is known as solubilizer in mixed solvency concept, which was started in the year 2009. But only thing will be, whatever the name of any molecule you take, that molecule possesses good solubilizing power for some solutes and bad solubilizing power for other solutes. Just like in case of liquids. Now I will give examples. How can we say? Firstly, before the application part of the solubilizing power of solids, I would like to explain with proof that how can we say that gases possess solubilizing power and solids possess solubilizing power. Firstly, I will discuss about the gases because they are not in this PowerPoint presentation. So, firstly, the examples of gases. If a gas is liquefied, the molecules come in liquid state, and these molecules of gases which are in liquid state may be involved in hydrogen bonding and weak bond forces with the molecules of solutes for their dissolution. For example, in supercritical fluid technology, CO2 gas at a particular pressure and temperature, it is liquefied, and this liquefied CO2 is used to carry out different functions. For example, to prepare nanoparticles of the drugs, for the extraction of active constant from herbal powder, for the purification of the materials, etc. So ultimately, liquefied CO2 is being used as solvent. Okay, now, but this liquefied CO2 is also not good solvent for each and everything, because when there is solubility problem with the liquefied CO2, we have to add other co-solvents like methanol, ethanol, etc. to improve the solubilizing power of liquefied CO2. So, of course, in supercritical fluid technology, I'm talking about. So now you may see for such substances where we employ co-solvents like ethanol, methylene, for those materials, this liquefied CO2 is not good solvent. Okay, so this is the example of gas. Okay, any gas if you liquefy, whether oxygen, helium, etc., that will be good solvent for some and bad for others. Only the reason will be the liquid, say for example, in supercritical technology, liquefied CO2 molecules, they are in a liquid state, and these molecules are involved in hydrogen bonding and whatever forces with the molecules of drugs or molecules of solutes or molecules of active constituents like this. Okay. Now another way by which the molecules of a gas may come in liquid state is by dissolution in a solvent. If you get a concentrated solution of any gas and liquid, then of course the molecules of gas will come in liquid state, and they can demonstrate their solubilizing power by hydrogen bonding and weak bond forces. For example, concentrated hydrochloric acid contains about 38% weight by weight of dissolved HCl gas. Means 100 grams of concentrated HCl contains nearly 38 grams of dissolved HCl gas. When we open the bottle, you see the fumes of HCl gas, they come out. So what I want to say, concentrated hydrochloride contains about 38% weight by weight of dissolved HCl gas. Means in concentrated HCl, the molecules of HCl, they are present in liquid state. And now I am giving one example of a drug, nalidixic acid, which has got very good solubility in concentrated HCl, 5% solubility. Concentrated HCl solubility of nalidixic acid is 5%, very good solubility. We are not talking about the formulation, but what we want to say, we are seeing that a poorly water soluble nalidixic acid has got very good solubility in concentrated HCl. Why? The reason is the molecules of HCl are present in liquid state in concentrated HCl, and these molecules of HCl are involved in hydrogen bonding and whatever nalidixic acid in concentrated HCl. So this is the example that molecules of gas may come in liquid state by dissolution in a solvent. Okay. But if we utilize the solubilizing power of gases, it is costly affair, so we are taking it aside. Mostly now we will discuss about the solubilizing power of solids, which will minimize the use of harmful organic solvents. So before giving the examples or applications of solubilizing power of solid, I would like to go some examples that how solids can behave. I mean, solids will demonstrate their solubilizing power. I have told you that solid cannot dissolve anything. For example, ice cannot dissolve anything. But when ice is melted, water in liquid state, molecules are in liquid state, these are involved in hydrogen bonds. Similarly, the molecules of a solid should be in liquid state so as to demonstrate the solubilization. By making hydrogen bonding and solid become this state. Number one, by melting. If you melt a solid, molecules will come in liquid state. You dissolve a solid in a solvent, molecules will come in liquid state. Number three, by eutectic formation. I will give all these examples in my lecture. Number one, the example of melted urea. Melted urea, a clear color liquid centigrade, point of urea is solubilizing for one melted gram of sodium. Means you get a clear solution of it. Molecules of urea, they are in liquid state, and these molecules of urea take part in hydrogen bonding with one of the forces with the molecules of dichlorophene and sodium. That's why there is a very good solubility of dichlorophene and sodium in this melted urea liquid at 132 degree centigrade. If you cool this mixture, this solution, then definitely you will have a solid mass. But we are talking about the solubilizing power of melted urea at 132 degree centigrade. Suppose there was no solubilizing power in melted urea, then you could have obtained a suspension of dichlorophenic sodium. One more thing, since the melting point of dichlorophenic sodium 283 degree centigrade is very high as compared to the melting point of urea, so there is no melting of dichlorophenic sodium in melted urea. Rather, there is dissolution of dichlorophenic sodium. Urea is solid at room temperature. After melting, the molecules are in liquid state, and these molecules also possess solubilizing power. So, in other words, you may say melted urea is a solvent. Okay, we are not talking about the formulation at this time. Just these are the proof. Number two example is that of phenol. If you take 1 gram phenol in your test tube, and if you keep this test tube in a water bath at about 44 degrees centigrade, is the melting point of phenol. You will have 1 gram clear colorless melted phenol liquid. In this melted phenol liquid, the solubility of a poorly water soluble drug nalidixic acid is very large. About 500 milligram of nalidixic acid is nicely dissolved by 1 gram of melted phenol liquid. 500 means about 40-50% solubility of nalidixic acid in melted phenol. We are not talking about the formulation, but we are seeing a solid after melting, when its molecules come in liquid state, these molecules of phenol take part in hydrogen bonding and with one of the forces with the molecules of nalidixic acid. That's why you get large solubility of nalidixic acid in melting. So these are the proof of melting. Number two, this is another way by which the molecules of the solid may come in liquid state. This is by dissolution in a solid. So the three examples of three solvent, water, ethanol, and propylene glycol. Number one is solubility of ibuprofen in water at room temperature is 0.028% weight by volume, is very poor solubility of ibuprofen in water. Why there is poor solubility? Because the extent of hydrogen bonding at which one of the forces between the molecules of ibuprofen and molecules of water, it is limited, very poor. That's why you get poor solubility of ibuprofen in water. But when we employ 2 molar sodium benzoate solution, means 28.8% weight by volume solution of sodium benzoate in water. In this, the solubility of ibuprofen is tremendously enhanced. It is 2.390% in this 28.8% weight by volume solution of sodium benzoate. Now, how many times solubility enhancement is there? 2.3 solubility enhancement is there. Now, what is the reason for solubility enhancement? The reason is sodium benzoate, which is solid at room temperature, when it is dissolved in water, the molecules of sodium benzoate come in liquid state, and these molecules of sodium benzoate take part in hydrogen bonding and become ibuprofen. That's why you get large solubility of ibuprofen in sodium benzoate concentrated solution. So this was first example of dissolution. Number two means here the water was solid. Number two, the solubility is sparingly soluble. 1.7%, very poor solubility, again due to limited extent of hydrogen bonding and one of the forces between the molecules of phenol and molecules of fusamide. When we employ 15% weight by volume solution of niacinamide in water, in ethanol, 15% weight by volume solution. Here the molecules of niacinamide, they have come in liquid state, and in the solution, the solubility of fusamide is enhanced threefold. and the solubility in this solution is about 5%. In this, the molecules of thymol and molecules, they are in liquid state. Properties of this eutectic liquid, left hand side if you see, metronidazole benzoate has got very good solubility in this eutectic. About 200 milligram of metronidazole benzoate is nicely dissolved by 1 ml of this eutectic soluble drug. Why solubility has been enhanced? Of course, we are not talking about the formulation, but you see, the solubility enhancement is due to the hydrogen bonding and weak bondable forces between the molecules of thymol and molecules of metronidazole benzoate, molecules of menthol and molecules of metronidazole benzoate. So this is the reason. So what we are seeing, the solids, when they come, the molecules come in liquid state, they can take part in hydrogen bonding with bondable forces, and they can behave like solvent molecules like this. Left hand side, atenolol, anodazole, benzocaine, udazeta, etc. They have got very good solubility in this eutectic liquid. But right hand column, cetronidazole, less than 5 milligram means even 5 milligram of cetronidazole cannot be dissolved by 1 ml of this eutectic liquid. It indicates that this eutectic liquid is bad solvent for cetronidazole. Similarly, fusamide, nimesulide, aspartame, for all these compounds, this eutectic liquid is a bad solvent. These are the studies solubilizing power of this eutectic liquid for liquids. Left hand column, ethanol, propylene, glycol, benzyl alcohol, etc. They have got very good solubility in this eutectic liquid. On other hand, glycerin is immiscible in this eutectic liquid, or you may say insoluble in this eutectic liquid. Water is immiscible or insoluble in this eutectic liquid. Similarly, suppose you take you yourself find out the solubility of so many compounds. Say, for example, hundreds of compounds, if you check for their solubility in this eutectic liquid, some compounds will fall in this list, some will fall in this list. So you can say this eutectic liquid is good solvent for some compounds and bad solvent for other compounds. So this is the statement for this eutectic liquid. The same statement was there with the so-called solvent, name of any so-called solvent like etc. You take that solvent possesses good solubilizing power for some solutes and bad solubilizing power for other solutes. Similar is the case here. Similar is the case here. This eutectic liquid is good solvent for some compounds and bad solvent for other compounds. So this means this eutectic liquid is a solvent. And once it is proved that it is a solvent, this means whatever it contains must possess solubilizing power. So it contains two solids, thymol and menthol. Molecules are in liquid state. This move, of course, we were not talking about the formulation, but these are the proof that how can we say that solids have got solubilizing power. So after this, now we are coming directly to the hydrotropic solubilization, which is about more than 100 years old concept. In this hydrotropic solubilization concept, we employ the solubilizing power of solids when they are dissolved in water. So this we will discuss now. So firstly, some examples. The solubility of dichloronic sodium in water is very poor, is about 1 point. Solubility of dichloronic sodium by volume at room temperature. But when you apply, you see in the middle of your list urea, if we prepare a 60% weight by volume solution of urea and water, this is one of the hydrotropic solution. So 60% urea solution in water. For example, from the point of view of students, how will you make this 60% weight by volume solution of urea and water? 100 ml volumetric class, 60 gram urea crystal, sufficient water for dissolution and volume makeup with water. So this is 60% weight by volume solution of urea and water. The solubility of dichloronic sodium in this particular concentrated solution of urea is about 4.8%. 4.8%, in water it was 1.6%. It's very soluble. So 4.8 divided by 1.63 fold enhancement in solubility is there, that of dichloronic sodium. What is the reason for solubility enhancement here? The reason is the molecules of urea, They are in liquid state, and these molecules of urea take part in hydrogen bonding and with one of forces with the molecules of dipropanic sodium. That's why you get large solubility of dipropanic sodium in concentrated solution of urea. This is one example of hydrotropic solubilization. Hydro means water. Hydrotropic solubilization relates with solubility enhancement in aqueous solution or in water only, not in other solvent, not in chloroform, not in ethanol, etc. No, but only in water or aqueous solution. As you are seeing here, the solubility of dichloride sodium is increased in aqueous solution of urea. So hydrotrophy means solubility enhancement in aqueous solutions or in water. So this is one example of hydrotrophic solubilization, which is about 100-year old concept. Another example is salicylic acid. The solubility of salicylic acid at room temperature in water is about 0.3% weight by volume, 0.3% weight by volume, percent weight by volume. This is the solubility at room temperature in water. Now we are preparing a 45% solution, weight by volume solution of sodium citrate in water, 100 ml volumetric flask, 45 gram sodium citrate, sufficient water dissolution, volume vapor. So this is 45% weight by volume solution of sodium citrate in water. In this solution, the solubility of salicylic acid is more than 15%, more than 15%. So 15 divided by 0.3, more than 50-fold, 50, more than 50-fold enhancement in solubility there. This is another example of hydrotropic solubilization. Here in this case, what is the reason for solubility enhancement? The molecules of sodium citrate, they have come in liquid state in this solution, and these molecules of sodium citrate, they take part in hydrogen bonding process with the molecules of salicylic acid. So anyway, this was another example of hydrotropic solubilization. Third, hydrotropic is, say, for example, sodium benzoate, left hand column, sodium benzoate. If you prepare, say, 25% solution of sodium benzoate in water, it's a concentrated solution of sodium benzoate in water. The solubility of several poorly water soluble drugs is enhanced. Largely, you may say, sometimes 5-fold, sometimes 50-fold, sometimes 100-fold, sometimes 1,000-fold. So the solubility of several poorly water soluble drugs is enhanced in concentrated solution of sodium benzoate. So these all are also the examples of hydrotropic solubilization. Now I am naming those drugs which are poorly water soluble and of which the solubility is enhanced in sodium benzoate solution. Ofloxacin, gatifloxacin, trinidazole, metronidazole, naproxen, ibuprofen, ibuprofen, nalidixic acid, hydrochlorothiazide, pyroxenium, etc. So these all were hydrotropic solubilization examples. Now the definition of course, the list before you, this is a partial list of hydrotropic agents. Partial list. Okay. Now, what is the definition of this hydrotropic solubilization? Two things are important. Solubility enhancement in water will be there. So aqueous water is important, and always we have to imply concentrated solution of hydrotropic agent. So definition: when there is enhancement in aqueous solubility of a poorly water soluble drug in the presence of a large concentration of an agent, then we call this phenomena to be hydrotropic solubilization phenomena. Again, I am repeating: when there is enhancement in aqueous solubility of a poorly water soluble drug in the presence of a large concentration of an agent, then we call this phenomena to be hydrotropic solubilization phenomena. Okay. Now, hydrotropic solubilization is more than 100 years old concept, but no one has implied its, you may say, solutions, hydrotropic solutions to replace organic solvent. But from the year 2004, when I was doing my PhD, I have started the application part of this hydrotropic solutions in various types of analysis and so on and so forth, which I shall be discussing in my later part of my lecture. Okay, so now and one more thing, let me tell you, whether you are a student or teacher or researcher, you can at the end of the lecture I will give my WhatsApp number. You can ask a large number of examples and all that, because in a small time I cannot explain each and everything. So you can ask for this and all that, and if you have any query in future also, then also you can contact me. Okay. Now, firstly, we'll discuss eco-friendly titrimetic analysis of poorly water-soluble drug using hydrotropic solution without using organic solvent. Now, the assay of furosemide API. Students should know what is this assay. You know that manufactured. So a large means drums. They are drums of 25 kg, 50 kg raw material or API ectopharmaceutical ingredient. They are purchased, and then to confirm the percent purity of this API, you have to carry out an assay method. So IP 2022, here it is written 18, but in new IP of 2022 also the same procedure is there, and even in BP also the same procedure is there. What is this pharmacopoeial method? Weigh accurately about 0.5 gram furosemide API. You have weighed, dissolve in 40 ml of dimethyl formamide, which is good solvent for this furosemide. Of course, this solvent means dimethyl formamide is the class 2 organic solvent. You are getting a clear solution of furosemide and DMF, dimethyl formamide. Then few drops of bromothiamine blue in solution indicator they are added in the solution, and titration is performed using 1.1 molar sodium hydroxide solution. At the end point, you have to note down the volume of NaOH consumed. Suppose this volume at end point is x1 ml. Then you have to carry out a blank determination. So how this blank determination is carried out? You will use another neat and clean conical flask. You will take 40 ml of dimethyl formamide in that. Few drops of bromothiamine blue indicator added, and we run 0.1 molar NaOH solution. As soon as you get the end point comes with very small volume of NaOH. Suppose it is Y1 ml. So this Y1 ml has been consumed by your solvent system itself. So this will be subtracted from X1. So X1 minus Y1, this much volume of NaOH has been consumed by your drug. Using the factor given in at the bottom of this slide, 1 ml of 0.1 molar NaOH is equivalent to 33.07 milligram of furosemide. You can find out the drug content of your API. So this is pharmacopoeial method, which is employing dimethyl formamide, which is a class 2 organic solvent. Now, when you will perform the titration using dimethyl formamide, it is volatile. These organic solvents, they are volatile. So the vapors of dimethyl formamide, they will be inhaled by you if you are performing the estimation using dimethyl formamide. Now, another thing comes there. Why pharmacopoeia person they have not employed ethanol? Because ethanol is a safer, relatively safer than dimethyl formamide. Ethanol is a class 2 organic. Why they have not employed ethanol? The reason is that there is poor solubility of furosemide in ethanol. It is sparingly soluble. 1.7% is the solubility in ethanol. So pharmacopoeial persons, they could not employ ethanol for its resolution for titrimetic analysis. So that's why they have used a strong solvent for furosemide, which is dimethyl formamide class 2 organic solvent they have employed, and they were performing the titration. Now I will give one example here itself, that you can employ the solubilizing power of a solid to improve the solubilizing power of a class 3 organic solvent like this ethanol to act as solvent like dimethyl formamide. How? If you dissolve 15% niacinamide, means if you prepare a solution containing 15% midway volume niacinamide in ethanol, this solution is now a strong solvent for furosemide, and in this solution, means in 15% niacinamide in ethanol solution, the solubility of furosemide is 5%, soluble category 5%, very good solubility. Now, in place of 40 ml of dimethyl formamide, I have employed 40 ml of this ethanolic solution of niacinamide to dissolve 0.5 gram API. Clear solution was there, bromothiamine blue indicator, NaOH for titration, and a blank determination was done, and same results were there. Now, I want to tell you what the difference between these two. In pharmacopoeial method, you are using dimethyl formamide, which is a class 2 organic solvent, which is very harmful for human beings. But I have made ethanol a strong solvent using solubilizing power of nationwide is solid. So we have got improved solubilization, and this solution itself was used for trichromatic analysis of APIs to summarize. Now, in this case, now there will be vapors of ethanol which are safer, relatively safer than vapors of dimethyl formol. So, in this way, this is one example that you can potentiate the solvent power of a class 3 organic solvent, ethanol, to act as class 2 organic solvent, dimethyl formamide. This is one example. In my another part of my lecture, I will give another example. How can you potentiate the solvent power of a class 3 solvent to act as class 2 solvent? Okay. Now, after this, again, let me say that this method is that of IP, pharmaceutical method, where you are performing titration with dimethyl formamide in dimethyl formamide solution. But now I will tell you, even without this dimethyl formamide, without any organic solvent, also you can perform the trichromatic analysis. Now you see this green method. Assay of fusimide API hydrotropic analysis. Weigh accurately about 0.5 gram fusimide API. Dissolve in 40 ml of 30% weight by volume sodium benzoate solution, which you may say either you may say it is a hydrotropic solution, or in other words, you may say as a result of solubilizing power of a solid, means sodium benzoate, the molecules are present in liquid state. This solution is being used as solvent system to dissolve your insoluble water insoluble drug fusimide. So anyway, what we have done, you have dissolved 0.5 gram of fusimide in 40 ml of 30% sodium benzoate solution. You get a clear solution. Few drops of room thermal indicator. You will use 0.1 molar annual solution for titration. As soon as end point comes, suppose the reading of annual solution is x2 ml. X2 ml. Now you will have to carry out a blank determination. Another conical flask, 40 ml of sodium benzoate solution, 2 drops room thermal indicator. Anyway, suppose the end point comes by use of Y2 ml of annual solution, few ml of course. So this Y2 will be subtracted from X2. So X2 minus Y2, this much volume of NaOH has been consumed by our drug. Using the same factor of pharmacopoeia, 1 ml of 0.1 molar NaOH is equivalent to 33.07 milligram fusimide. You can find out the drug content. Now you see the beauty of this method. Number one, as far as the cost factor is concerned, the cost of 1 liter of 40% weight by volume sodium, this cost of 30% sodium benzoate solution in water is nearly rupees 40 per liter. 40 rupees per liter means you can have 1 liter of sodium benzoate solution 30% in nearly 40 rupees. Okay. The cost of methanol, ethanol, etc. is nearly 200, 250 rupees per liter, etc. Like this, like that of dimethyl formamide and all that. Number one, your method is economic, very economic. Number two, when you will perform the trichromatic analysis, you are using aqueous solution of sodium benzoate. Sodium benzoate is not volatile. It does not evaporate out. It does not go inside your body by inhalation. No, it does not go. Means your method is free from organic solvent. So not only it is cheaper method, economic method, but main thing is that human being or the persons who are involved in such analysis, they can be prevented to some extent against the harmful effects of, you will say, the vapors of organic solvents like this. Okay, so our method is eco-friendly or green chemistry method is there. If you have any doubt, please note down your question. At the end of the lecture, you will find the solution. Now coming to another example, that is flurbiprofen. We are discussing the trichromatic analysis of poorly water soluble drug. Flurbiprofen API pharmaceutical method utilizes ethanol for its dissolution to carry out trichromatic analysis. Ethanol has been replaced by sodium benzoate solution in the same way as we have seen in case of fusimide. Naproxen API utilizes methanol, which is a class 2 organic solvent. This methanol can be replaced by sodium benzoate solution. Okay, I am trying that some of these methods should be included in pharmacopoeia course in IPC Ghaziabad lab, from where our IP comes. They have checked the, you may say, the accuracy of these methods. They have compared this naproxen method and furosemide in presence, in my presence. They have checked, and same results are there. Anyway, now coming to salicylic acid involves the use of ethanol for its absorption for titanic analysis. It has been, means ethanol has been replaced by sodium citrate solution, hydrotropic solution of sodium citrate. This solution is also economic, just like means 40 rupees per liter solution of sodium citrate can be made economy. So this solution is again an economic hydrotropic solution. Ketoprofen utilizes ethanol. Ethanol can be replaced by sodium benzoate solution. It has been replaced. Ibuprofen API, ethanol is used, has been replaced by sodium benzoate solution in the same way. Now, the essay of ibuprofen tablet, IP 2018, IP 2022, actually, I have not seen, I have not actually checked, rather I should say that I have not checked this. Maybe that same procedure may be there, but anyway, I am saying that IP 2018 utilizes this method where two organic solvents are involved. Weigh and powder 20 tablets, average weight is determined. Weigh accurately the powder equivalent to 0.5 gram of ibuprofen. Extraction is performed with chloroform three times in pharmaceutical method. Then chloroformic extracts, they are mixed, and then evaporation of chloroform is carried out in air current to get a residue. Then that residue is dissolved with the help of 100 ml of ethanol. 2 drops of phenolphthalein indicator they are added, and titration is performed with NaOH solution. Suppose the reading is X3 ml. Carry out the blank determination. You have to carry out a blank determination. Another conical flask, 100 ml of ethanol, 2 drops phenolphthalein, again NaOH for endpoint. Suppose Y3 ml is consumed. So X3 minus Y3. So this much volume of NaOH has been utilized in this stoichiometric analysis using the same factor. Each ml of 0.1 molar NaOH is equivalent to 0.02063 gram of ibuprofen. You can find out the drug content. Basically, what you have done here, you have employed two, means pharmacopoeia. Pharmacopoeia method implies two organic solvents: chloroform, which is class 2 organic solvent; ethanol, which is a class 3 organic solvent. Now, without these two organic solvents, also you can perform the titanic analysis by hydrotropic solubilization technique. Assay of ibuprofen tablets by eco-friendly or green chemistry method. Weigh the tablet powder equivalent to 0.5 gram of ibuprofen. Shake briskly for 10 minutes with 100 ml of 30% sodium benzoate solution, hydrotropic solution. So during this shaking for 10 minutes, this sodium benzoate solution dissolves the ibuprofen present in the tablet powder. Few drops of phenolphthalein they are added, and titration is performed with 0.1 mol of NaOH. Suppose the volume of NaOH consumed is X4 ml of NaOH solution here. Blank determination using 100 ml of sodium benzoate solution in another conical flask. Suppose reading is Y4 ml, Y4, so X4 minus Y4, this much volume has been consumed in your titanic analysis using the same factor of pharmacopoeia. 1 ml of 0.1 molar NaOH is equivalent to 0.02063 gram of ibuprofen. You can find out the drug content of the tablet. Now see the beauty of this method. What you are implying here, you are implying only hydrotropic solution of sodium benzoate. No organic solvent, no ethanol, no chloroform. So without any organic solvent, you are using just hydrotropic solution to carry out the titanic analysis. Same results are there, with 100% accuracy. All these results are with 100% accuracy. So in this way, you can say this your method is economic. Main thing is that neither there are vapors of chloroform which are being inhaled by human beings. No vapor. Sodium benzoate does not evaporate out. Now, similarly, these estimations can be done. They have not been done by me. Ethyl vanillin, dimethyl bromide can be replaced. That of pharmacopoeia can be replaced by hydrotropy. Indomethacin, acetone can be replaced. Glibenclamide, ethanol can be replaced. Chlorpromide, ethanol can be replaced. Mefenamic acid, ethanol can be replaced by hydrotropic solution. After titanic analysis, now coming to UV spectrophotometric estimations of pharmaceutical dosage forms of poorly water soluble drug using hydrotropic solutions without organic solvents. Green chemistry example is that of assay of indazole tablets. IP 2018 it is given here, but also in latest IP 2022 the same procedure is there. I think it should be the same. Actually, perhaps I have not checked, but it should be anyway. But IP 2018 method we are discussing. Weight tablet powder equivalent to 0.15 gram of indazole. It is taken in a 100 ml volumetric flask. 20 ml of methanol is added, subsequently shaken. Then volume is made up to the mark, means up to 100 ml with methanol. Then to remove insoluble excipients, you have to filter it out. This is a pharmacopoeia method. Then from the filtrate, you will take 10 ml and it is diluted up to 100 ml with methanol. Again, from this solution, you will measure 10 ml solution and dilute it up to 100 ml with methanol. And the absorbance of this solution is noted at 310 nm, 310 ml against methanol. Since your solution means drug is present together with methanol, so in the reference cover you will put methanol, which you will say it is a reagent blank, and you find out the absorbance at 310 nm, and then you have to calculate the for the content of indazole taking 356 as the specific absorbance at 310 nm. This is E1% 1 centimeter value specific absorbance at 310 nm. In case of this methanol, the peak of indazole comes at 310 nm. But if you change the solvent, there may be shifting of peak. So anyway, in this pharmacopoeia method, pharmacopoeia is employing methanol, a class 2 organic solvent. The vapors they are inhaled, they do harm to the human being. Now, without methanol, we will perform by use of hydrotropic solution. Wheat tablet powder equivalent to 50 milligram of indazole. Add 20 ml of 30% sodium benzoate solution and shake for 10 minutes in a 25 ml volumetric flask. So tablet powder, 20 ml sodium benzoate solution in 25 ml volume, 10 minutes shaking. During this 10 minutes shaking, this sodium benzoate solution dissolves the indazole which is present in the tablet powder. Then make up the volume up to 25 ml with water and then filter to remove insoluble excipient. Dilute 1 ml of filtrate up to 100 ml with distilled water, and the absorbance of this solution is noted at 318 nm against reagent blank solution. In water, the peak of indazole comes at 318 nm. Due to change in solvent, methanol 310, water 318 nm. So in this way, you have to measure the absorbance of this solution where the drug is present together with sodium benzoate. So for making the reagent blank from the point of view of a student, you will have to make reagent blank. 25 ml volumetric flask, 20 ml of 30% sodium benzoate solution. Up to the mark means 25 ml you have to dilute with water. From this solution, you will take 1 ml and dilute it up to 100 ml with water. So this is the reagent blank solution which contains same concentration of sodium benzoate which is present together with your drug. What is the concentration of drug in that solution, in sample solution? You can check like this: 50 milligram indazole diluted up to 25 ml, from 2 milligram per ml, 2000 microgram per ml. 1 ml diluted to 100 ml means 100 times dilution. 2000 mg per ml, 100 times dilution, 20 microgram per ml. So this your sample solution contains 20 microgram per ml of drug, nearly 20 microgram per ml, together with sodium benzoate, and in your reagent blank solution only sodium benzoate solution is there. The concentration of sodium benzoate solution are same in both these solutions. They will neutralize the effect of each other. Absorbance at 318 ml will be due to your drug itself. So what you have done, you have find out, you have noted the absorbance of this solution against reagent blank. Okay, then there are two methods by which you can calculate the drug content in your tablets. Calculate the content from the absorbance obtained by repeating the whole procedure using 50 milligram indazole RS in place of 10 tablet powder. RS means reference substance, 50 milligram indazole. When we get the sample from the companies, the drug content is written on the label. Say suppose they have written that 99.08% of drug tendazolate content. This means based on this drug content, you will have to measure 50 to weigh 50 milligram of sample to get means sufficient sample to have 50 milligram of pure tendazole. It will be dissolved with the help of 20 ml of 30% sodium solution in a 25 ml volumetric flask. Volume is made up to 25 ml mark with water. 1 ml from this solution diluted up to 100 ml with water. In this way, you will have 20 microgram per ml standard solution. And reagent blank is same which I have given the procedure to make it. So using this reagent blank, keeping reagent blank in reference covered, will find out the drug and you have absorbance of this solution at 318 nm. Similarly, yes, and now by comparison of these two absorbances, previous one which we have noted, and this one from the standard drug. If you compare these absorbance, you can find out the drug content. Number one method. Number two method. You can make elevation curve of your drug. How? You take pure means drug, means bulk drug, sufficient weight containing 50 milligram accurately of indazole. You will go in the same way. You will get a standard solution containing 20 microgram per ml. And the same, and the reagent blank is same. Now, in case of 10 microgram per ml, double dilution of this reagent blank. So, you will put this reagent blank for 10 ml per ml. Similarly, 5 reagent blank of 5, 10 reagent blank of 10, 15 reagent blank, 20 and 25. 5 standard solutions, 5 respect to reagent blanks, absorbances at 318 nm. Using these absorbances, you will plot the calibration curve. This will be used to carry out this estimation, hydrotropic estimation. Okay. Now, two things are important here. Number one, the cost of your sodium benzoate solution is means it is very economic solution. Number one. Number two, sodium benzoate does not interfere above 292 nm. So at 318 nm, there is no UV interference of sodium benzoate. Sodium UV in UV estimation, sodium benzoate does not interfere above 292 nm. So always whenever you use sodium benzoate as hydrotropic agent, you will have to select such a peak of drug which is away from 292. For example, in case of metronidazole tablets, 320 nm was used. Indomethacin 390, like arnidazole 390, like this. Indomethacin 320 nm, like this. So in this way, this you have to keep it in your mind. Means before 292 nm, you are not supposed to use sodium benzoate, or of course another hydrotropic agent, they are not used in these estimations. So anyway, number one, what you have done here by using this hydrotropic method of sodium benzoate, you have replaced a class 2 organic solvent methanol of pharmacopoeia by hydrotropic solution of sodium benzoate, which is cheaper, means economic, as well as it is non-volatile. It does not harm to the human body. Now, similarly, naproxen tablets, they have been estimated using sodium benzoate as hydrotropic agent. Methanol of pharmacopoeia has been replaced by sodium benzoate. Indomethacin, and of course, in naproxen 331 nm absorbent to use. Indomethacin 320 nm methanol has been replaced by sodium benzoate. Diazepam 354 nm methanol has been replaced by mixed hydrotropic solubilization. So there are so many things. Now, if you want to carry out before 292, so I am giving two examples of atenolol tablet and dipropanol sodium tablet. Atenolol tablets IP method include methanol, means it is methanolic method, total methanolic method. But I have used urea solution, hydrotropic solution of urea to increase the solubility of atenolol. So urea solution concentrated was used to estimate atenolol tablets at 275 nm. 275 nm. In the same way as we have estimated tendazole using sodium benzoate solution. So urea solution was employed to estimate atenolol tablet to replace methanol of pharmacopoeia method. Methanol has been replaced by urea solution. Urea does not interfere above 240 nm in UV analysis. Above 240 nm, urea does not interfere. That's why in case of atenolol, 275 nm was used for its estimation. Dichlorofenic sodium tablet analysis by pharmacopoeia, methanol is used. This class 2 methanol has been replaced by urea solution. Urea solution does not interfere above 240 nm, I have told you. So in case of dichlorofenic sodium, the estimation is done at 275 nm. So urea solution has replaced methanol. So of course, so many examples are there, and so much work has been done in India. Now, see, I have told you that when I was doing my PhD from 2004, from the year 2004, and up to this time, 2021, a book has been written on this work. And so, in so many years, so much work has been done in India, not only in India, in abroad also, that a chapter in a green chemistry book has been written by four foreign authors. Foreign authors, one from Saudi Arabia, one from Egypt, one from two from of course from Saudi Arabia, one from Japan. So these four associate professor type of say which is academicians, they have written this chapter. This is the chapter number 6, Green Hydrotropic Technology, and this has been written in a green chemistry book which contains 13 chapters. And this book is of Expenditure publication, which is one of the best international publisher. So now this work has been recognized in all over the world, and of course this work has gone from India. The origin of this work was in India. What I want to say you, just like this, whatever I'm going to discuss, other things, they will all appear in some chapters in the same way, also in the textbooks, also in pharmacopoeia, and all they will come. Because our objective is to minimize the use of harmful organic solvent to prevent, to safeguard the human health against, you may say, the harmful effects of vapors of harmful organic solvents and so on and so forth. So this is our main objective. Okay, and if you have any doubts, please note down your question at the end of the lecture. We have question answer session. Now coming to third type of analysis, that is thin layer chromatography using hydrotrophy, means green chemistry. You see, up to this time, whatever the TLC you will see from books or any standard books or pharmacopoeia, etc., always at least one organic solvent is there, one or two, three maybe there. Now I will tell you, you can carry out the TLC of each and every compound using hydrotropic solutions or mixed hydrotropic solutions or mixed solvent system. Okay, I will tell you. One example I will give one published paper, which this work has been done in our lab here. Employment of hydrotropic and mixed hydrotropic solutions as mobile phase to carry out TLC precluding the use of organic solvent. This published paper is available online on Google search. What work has been done by M.Pharm students here? Here, 9 water-soluble drugs were selected by 3 M.Pharm students. 9. Propanol hydrochloride, guaifenesin, and up to this losartan potassium, 9 water-soluble drugs were selected, and the 2% aqueous solution of all these drugs means 9 drugs, 9 solutions. 2% aqueous solutions, they were employed using capillary to put the spot on the TLC plate of silica gel G. These plates, after putting the spot, they were kept in oven for the removal of water. When the spot was fixed, then mobile phases of hydrotropic solutions or mixed hydrotropic solutions, they were employed to carry out the TLC plate. What were those solutions? Students prepared 8 blends, 8 different blends of hydrotropic solutions. Blend 1, 5% sodium benzoate, 5% sodium acetate. No any other solvent other than water, no organic solvent. Blend 2, 5% sodium benzoate, 5% diazonamide. Blend 3, sodium benzoate, sodium citrate. Blend 4, alone, sodium benzoate, 10% solution. And of course, the 8th blend was this one for propanol hydrochloride, 7.5% diazonamide and 7.5% sodium benzoate. I told the students to use all 8 blends for each and every drug to carry out TLC. So 8 into 9, 72 times this TLC plates they were developed. Okay. I told the student to select such a mobile phase of hydrotropic solution which gives spots without telling effect. For example, in case of propanol hydrochloride, this blend, its blend was only successful to give spots without telling effect. Other blends were not good, means they did not give good spot without telling effect. And of course, the RF value was 0.80. Guaifenesin, another drug. Blend 1, 2, 3, 4, 7. They were selected. They gave spots without telling effect. Okay. In case of cephalosporin only one blend was there. Lidocaine article, so many blends like this. So in this way, after development of the plates, what was done? After the plates were developed, these plates were kept in oven for removal of water, and then spot identification, iodine chamber they were employed. Now, I would like to tell you, if you see the examples of 5 drugs out of these 9 drugs, the IP method, pharmaceutical method, they employ dichloromethane, methanol, acetonitrile. In case of guaifenesin, क्यों आप रोक नहीं पा रहे हैं इनको? अब भी जाओ, रोको, कितना हल्ला आ रहा है? डांटो जरा उनको. आई एम सॉरी, एक्चुअली स्टूडेंट्स का पेपर छूटा है तो हल्ला हो. चलिए, guaifenesin, the TLC plate they are carried out, they use means in TLC they use carbon tetrachloride, which is class 2 organic solvent, and ethanol, which is class 3 organic solvent. Okay, so in this way, what I want to say now means without the use of any organic solvent, you can perform the TLC for each and every compound. If your compound is water soluble, small concentrations of hydrotropic agents will be required for development of the plate. If your drug is insoluble type of drug, then a higher concentration, maybe 25%, 30% blend, they will be used to carry out the to develop the TLC plates like this. Okay. Now, after this HPLC using hydrotropic method, novel, this is the published paper reference. Novel reverse phase HPLC method development and validation of cetirizine in bulk and its dosage form by using hydrotropic solution as mobile phase. This work has been done by Remy SL madam. She is assistant professor in Kerala. This is her PhD work. And in this work, cetirizine tablets have been analyzed by Remy madam using 6% weight by volume aqueous solution of sodium acetate after adjusting its pH to 6.2 with the help of acetic acid. So this solution was used as mobile phase. Means this is the hydrotropic solution of sodium acetate, 6%. No other any organic solvent, no methanol, no acetonitrile, etc. And this mobile phase was used to carry out this work. Published paper reference I have given to you. This work is available online. She has also carried out one more published paper of Remy madam in this. A novel eco-friendly cost-effective mobile phase for HPLC, simultaneous estimation and validation of paracetamol and dichlorophenic sodium in bulk and pharmaceutical formulation by reverse phase HPLC using hydrotropic solution as mobile phase. So the tablets containing 2 drugs simultaneously, paracetamol and dichlorophenic sodium. These were assayed. The analysis of such tablets was carried out by reverse phase HPLC by Remy madam, and this published paper is available online. A large number of validation parameters have been carried out by madam, and here she has employed 5% urea solution as mobile phase, aqueous solution of 5% urea without any organic solvent. Okay, so in this way, reverse phase HPLC of compounds can be performed using hydrotropic solutions or mixed hydrotropic solutions. Only thing will be here, there are certain limitations. For all water soluble compounds, you can perform reverse phase HPLC using smaller concentrations of hydrotropic agent. But for poorly water soluble drugs, there is a limitation because a large pH or you say the large concentrations of hydrotropic agent cannot be employed as mobile phase to carry out reverse phase HPLC. That's why if you want to select this type of work to do, select the water soluble compound and then you perform its reverse phase HPLC using hydrotropic solution or mixed hydrotropic solution using smaller concentrations of hydrotropic in 2%, 3%, or blends of 4% or 3%, like this in this way. If you have any question, please note down your question. Now, after this mixed hydrotropy, I've told you that hydrotropic solubilization is more than 100-year-old concept. No one has employed mixed hydrotropy. We have started here this mixed hydrotropy from the year 2008, and mixed hydrotropy is very useful. You see, I told you that hydrotropic solubilization is more than 100-year-old concept. But and so many persons they have made intramuscular injection using single hydrotropy and large concentration of hydrotropy agent, but these formulations could not be marketed due to large concentrations of hydrotropic agents, which may be toxic. I will explain this with the help of a table. This table is means that these are the additives which have been employed or which are employed in aqueous intramuscular injections. They have been brought for you from Inactive Ingredient Guidebook, 2019 book. It is not 20, it is 2019 book. Inactive Ingredient Guidebook. It is a thick book which gives various concentrations of additives which can be safely applied in various types of pharmaceutical formulations. So from that book, these are the this is the list of those additives which can be employed in aqueous intramuscular injection safely. Safely means from the point of view of toxicity. Okay. Now, so from this list, now we see number 13, sodium benzoate 10%. You cannot employ 15% or 20% sodium benzoate in aqueous intramuscular injection because maximum limit given in this particular book is 10%. Now, so whatever the scientists or researchers they have made the intramuscular injection so far using single hydrotropy by 30% sodium benzoate solution or 20%, these formulations cannot be marketed because they contain more concentration of sodium benzoate than is permitted in aqueous intramuscular injection so far. Okay, now I will tell you how the marketable formulations can be made with the help of mixed hydrotropy. Now you see number 13 is sodium benzoate 10%. It is safe in aqueous intramuscular injection. Now you see number 8, it is sodium acetate 10%. It is safe in intramuscular injection. You see number 2, sodium citrate 10%. It is safe. So using these 3, 10, 10%, 30% solution of mixed hydrotrophic solution, if the drug of the solubility of your poorly water soluble drug is enhanced sufficiently in this mixed hydrotrophic solution, then this solvent system can be used to make aqueous intramuscular injection of your poorly water soluble drug, because this solution contains the safe toxic from the point of view of toxicity safe concentrations of 3 hydrotropic agent. So in this way, mixed hydrotropy can solve the problem of toxicity issue, and that can be employed to make marketable formulation. And one more thing I would like to inform you that in Egypt there is a scientist, Dr. Hossein Misri. He has seen these mixed hydrotropic published paper of mine, and they have been referred by him. He is still using this mixed hydrotropy to develop marketable formulation. As we have discussed on, I've given lecture of about 90 minutes to him alone, and he told that he is still using mixed hydrotropy to make marketable formulation. Now, from here itself, I would like to explain one more thing. This mixed hydrotropy is good, but still better is mixed solvency concept. I told you the concept of mixed solvency concept I have started in the year 2009, 2 parameters, and that number 1 parameter says that each and everything present in this universe has got solubilizing power. Number 2 parameter, since all materials possess solubilizing power, particularly from the point of view of pharmaceutical formulations, we should imply the solubilizing power of additives, because additives may also have solubilizing power for your drug. So the second parameter of mixed solvency concept, if you take smaller concentrations of different safe additives, making a concentrated solution, and this solvent system, if it increases the solubility of your drug sufficiently, then you can employ this mixed solvent blend to make your formulation. For example, from this small table, which gives the safe concentrations of these additives which are employed in aqueous intramuscular injection, You can make innumerable safe solvent system using these small, means 19 items are there, 19 additives are there. Some are in 5% concentration, 17, 18, 19 benzoic acid, threonine, valine. Other are they are safe in even in 10%. So I am giving one example, one blend. If you mix three ingredients, number one, two, three, alcohol 10%, sodium citrate 10%, arginine 10%. Total is 30%. This is one solvent blend, mixed solvent blend. If you change arginine, if you replace arginine by histidine, another blend is ready, solvent blend is ready, mixed solvent blend is ready. So by permutation combination, just using this small table, you can make innumerable safe solvent system for what? For intramuscular, aqueous intramuscular injection of holy water solvent drug. So in this way, you are seeing that mixed solvency concept have second parameter that each thing, each material have got solubilizing power. So we can imply solubilizing power of all these additives. But only thing will be you will have to find out the solubility after making these solvent blends. Now coming to the same slide from where we have come here now. So this is mixed hydrotrophy. This is the M-Pharm project done by Hitesh Jagmani, M-Pharm student. Those the researchers or students, those they need the soft copy of these M-Pharm projects, I can send soft copies to you also. If you want, you can have or what, so that you can see systematically that how to proceed for your project and all that. Anyway, now saying this particular work, this it is has used fusimide as model poorly water soluble drug. Water solubility is obtained about 0.008%. Then four hydrotropic agents were employed by him. Urea 40%, sodium acetate, sodium benzoate, sodium all 40%. Solubility in all these solutions are before you. Among these four hydrotropic solutions, solubility was maximum in case of sodium benzoate 2.157%. Then I told him to make 15-20 blends of mixed hydrotropic solution, keeping 40% concentration constant just by varying the proportions of all these four hydrotropic agents. Then from there, the solubility of fusimide was checked in all those blends. Out of those three examples I am giving for you, number 6, 15% sodium benzoate, 5% sodium acetate, 5% sodium citrate, 5% urea. Total is 40%. In this particular mixed hydrotropic solvent blend, the solubility was 4.247%, means nearly double than that of sodium benzoate. Means here synergistic solubilizing power was there. So if you have synergism, smaller concentrations of hydrotropic agent can be implied to make a formulation. So anyway, mixed hydrotropy can give additive solubilizing power. It can give synergistic solubilizing power, but only by trial and error. And then this mixed hydrotropy can be used to make marketable formulation, as I have explained. Now the second parameter of mixed solvency concept, that since all materials possess solubilizing power, this means the additives may also possess solubilizing power for your drug. I have made one aqueous mixed solvent blend containing 4 solids. Sodium benzoate 5%, caprylic, citrate 5%, fluoxol 0.05%. Total became 20% solution. So aqueous solution containing 4 solids. pH of the solution was 7, nearly neutral. It is neutral. Then the solubility of several poorly water soluble drugs was checked in the blend. These were checked by me. Now, two examples I am giving for you. Fusimide solubility in this blend, about 35 milligram per ml in this blend. Otherwise, in water, not even 1 milligram per ml, less than that. So at least 35 fold solubility enhancement is there. The reason for solubility enhancement is same. The molecules of all these 4 solids, they are in liquid state. For hydrogen molecules, one more force and all that. Now, so what can you do by using this hydrotropic mixed solvency system? You can employ this solvent system to make the aqueous injections. Like this, you see, fusimide, the marketed tablets, you say the dose is 20 milligram per tablet or 40 milligram per tablet. You can make 20 milligram per ml injection of this fusimide in this particular blend. 1 ml, 20 milligram per in solution form. due to solubilizing power of these four solids. So now you see 5% weight by volume means 100 ml of the solution contains 5 gram, 10 ml contains 500 milligram sodium benzoate, 1 ml contains 50 milligram. So 50 milligram sodium benzoate, 50 milligram citrate, acetate, caprylate, polar summer. 50, 50, 50, 50, 200 milligram were kept in a vial, and then 20 milligram of furosemide, 1 ml water to add, you will get a clear solution. So in this way, dry powder injection of reconstitution, they can also be developed. Not only the ready-made injection, but also dry powder injection for reconstitution. Suppose a drug is hydrolyzable, so ready-made injections cannot be made with sufficient shelf life or expiry period. So what can be done? You can utilize the solubilizing power of solid type of additives in safe concentrations. Then these solid these additives will be kept in vial together with your drug. At the time of need, you will add 1 ml or 2 ml of water, reconstitute, you will get solution, it will get like. So in this way, solubilizing power of solids can be employed for making dry powder injection for reconstitution, so that you can have sufficient expiry period of your formulation. Number two, the pyroxicam solubility in this particular blend was about 20 milligram per ml. Otherwise, in water, not even 1 milligram per ml. So anyway, so this is the second parameter of mixed solvency concept. Now I will give the applications of mixed solvency concept in different pharmaceutical dosage form. Dry powder injection for reconstitution of poorly water soluble drug can be certain selected for 1 ml injection. This is M for project. Published paper reference is given at the bottom. What has been done here? The student, M for student, has used 8 milligram with the dose of your water soluble drug candidate and selected. It was nicely dissolved by a solution made with the help of 100 milligram sodium caprylate, 50 milligram sodium benzoate, 50 milligram sodium acetate, in 1 ml of water. You will have a clear solution of this drug. So these dry materials were kept in vial. At the time of need, 1 ml water will be added. You will get a clear solution of your drug. 8 milligram is the dose of your drugs. And this way, this published paper reference is there. What other you can do with mixed solvency concept? You can prepare solid dispersion for fast dissolution of poorly water soluble drug. Furosemide, of course, was taken by M. Student. Published paper reference is before you. It is available in online PDF. It is available. And if you want soft copy of these theses, I can send to you. What has been done here? How it has been made? Minimum quantity of water was taken. In that, sodium citrate, sodium acetate, beta cyclodextrin, sodium caprylate, these were dissolved. Clear solution was there. Then, furosemide drug was added 2.5 gram. You will again get clear solution. Then, you will heat this on water bath using a magnetic stirrer. Stirring will be there. Removal of water, you get semi-solid residue. It will be kept in the oven for its drying. Then you will pass it through a fine sieve. This is a solid dispersion of your drug for fast dissolution. Mixed solvency concept can be used to make liquid solid systems of poorly water soluble drug. In liquid solid system, always a non-aqueous solvent is selected. Non-aqueous solvent may be propylene glycol, glycerine, PG 400, etc. Okay, now if the solubility of your drug, you first you see this example of MPAR project. A student has used pyroxicam as poorly water soluble drug. The solubility of propylene of this pyroxicam in propylene glycol was very poor, about 5 milligram per ml. The dose of pyroxicam in tablets is about 20 milligram. So if you want to dissolve a 20 milligram drug, you will need 4 ml of propylene glycol non-aqueous solvent. 4 ml means 4 gram. Then there will be absorbent will be needed, 12 gram, 14 gram like this. So you cannot make it tablet or capsule after making it free flowing. No, you cannot make. So what you will have to do, you will have to improve the drug loading in your propylene glycol using the solubilizing power of solids like this. In this case, 2 solids, sodium caprylate 10%, sodium acetate 10%, they were dissolved in propylene glycol. And in this mixed solvent system of these 2 solids and propylene glycol, the solubility of pyroxicam was improved about 24-fold enhancement in solubility was there. So the resultant solubility in this solution was about 120 milligram per ml. Propylene glycol 5 milligram per ml. In this blend, 120 milligram per ml. You assume it to be 100 milligram per ml. Suppose it is 100 milligram per ml. So 1 ml 100 milligram. 0.1 ml 10 milligram. 0.2 ml 20 milligram. So 20 milligram drug will be present in 2.2 ml of this solvent system. So 0.2 ml means nearly 200 milligram. Adsorption with about 600 milligram or 800 milligram MCC, microcrystalline cellulose, free to make it free flowing. Tablet can be made, capsule can be made like this. So by improving the drug loading using mixed solvency concept, the liquid solid system they can be made. Other applications of mixed solvency concept, aqueous injections ready-made can be made using solubilizing power of safe additive. Safe means from the point of view of toxicity. Mixed solvency concept has been used for this MPAR project. Dry powder injection for reconstruction of. This is another example of indomethacin, dry powder injection. But previously it was candesartan selexatil. Now we have this is indomethacin. Now these I have experienced. I'm leaving. Now coming to vaginal film have been made by MPAR student. Metronidazole was water soluble drug selected. Safe additives they were employed to improve the drug loading in vaginal film to reduce its size. Complete PDF is available online on published paper. Improvement of drug loading in ACDDS by drug selected was candesartan selexatil. Solid solubilizers were used to improve the drug loading in ACDDS system. Drug loading was improved in oral film, reducing its size using the solubilizing power of additives. Where then it is for this is another example on oral film. Drug is amlodipine bisalate. Published paper are available online. Solubilizing power of additives was employed to the drug loading to reduce the size of film. Now, another interesting thing now for 5 minutes, I would like to say, and then the lecture will be over, and we will have a question answer session. Now, solids can be employed for extraction also. So, briefly, I will explain to you how the solids can be used for extraction of ectoconstant from herbal powders. The published paper reference is eco-friendly extraction using solid. A novel application of mixed solvency concept. And this paper is available online. Now, what has been done? Briefly, I would like to discuss this one. Our MPharma student team, 5 students were there in this team, MPharma students. We have selected sesame oil as the ectoconstant, which is found in sesame seed powder, tilika tel, sesame powder. So, firstly, the solubility of sesame oil was checked in different solvent systems. For example, thymol, 1 gram, was taken in test tube, 1 gram thymol crystal. Melting point about 50 degrees centigrade. Water bath. At 50 degrees centigrade, you have clear, colorless melted thymol liquid mixed with wave-like solvent. In this 1 gram melted thymol liquid, 0.1 ml sesame oil was added. It was dissolved 0.1 ml. More than 1 ml of sesame oil is nicely dissolved by 1 gram melted thymol at about 50 degrees centigrade. This means melted thymol at 50 degrees centigrade, clear color liquid, very good solvent for sesame oil, then extraction was performed. How the extraction was performed? Test tube, 3 gram sesame seed powder, 9 gram thymol, 3 times more, 9 gram thymol, water bath, at about 50 degrees centigrade, melting of thymol was there. Melted thymol was used for extraction by shaking, 30 minutes shaking, heating, shaking, and like this 30 minutes shaking was there. During this shaking, melted thymol dissolved sesame oil which is present in the sesame seed powder, and then straining through cloth was done. Strained liquid containing melted thymol containing dissolved sesame oil was kept in oven at about 80 degrees, 70 degrees centigrade for the removal of thiamol. Thiamol was removed, then remaining was sesame oil. Sesame oil, of course, some traces of thiamol may be there. Of course, they were there. But what I want to tell you that melted solid has been employed for the extraction of your active constituents, means sesame oil here in this case. Similarly, melted menthol was good solvent. It was also employed in the same way 3 gram sesame seed powder, 9 gram menthol, and removal by heating at about 70 80 degrees centigrade in 1 hour. All thiamol or all menthol they are removed. Now coming to at room temperature extractor, ethanol. Ethanol is poor solvent for sesame oil. We have made a 50% solution of thiamol and ethanol randomly 50% thiamol and ethanol. In this solution, the solubility of sesame oil was found to be 1.4 ml. Sesame oil was dissolved by 1 ml of this solution at room temperature. Then 3 gram sesame seed powder, 9 ml of this solution at room temperature, 30 minutes shaking, filtration, filtrate, exposed to means was kept in oven at 70 degrees centigrade for removal of ethanol as well as thiamol. So ethanol was removed, thiamol was removed. Remaining behind was sesame oil containing some traces of thiamol, some traces of ethanol. What I want to tell you here is now I will mention another example by which you can make a class 3 organic solvent to behave like a class 2 here. Now see the industry persons of oil producers, with oil producers, what do they do? What do they use? They use hexane, class 2 organic solvent, for the extraction of sesame oil. Hexane is good solvent for sesame oil, but ethanol is a weaker solvent for sesame oil. That's why manufacturers could not employ ethanol for extraction of sesame oil from sesame seed powder. No, they employ either hexane or sometimes they potentiate the solvent power of ethanol by using a hexane mixture. So ethanol hexane mixture they were also employed for extraction. Removal of means after heating ethanol, hexane they were removed. Some traces of thiamol, some traces of ethanol and hexane they were there. Of course, the traces of hexane they were now less as compared to hexane alone. The traces of hexane they are very harmful for human being. But what I want to tell you now here, why they are using hexane? Because hexane is a class 2 organic solvent, which is good solvent for sesame oil. Why they are not employing ethanol? Because ethanol is a weaker solvent for sesame oil. I have made ethanol a strong solvent like hexane by utilizing solubilizing power of thiamol in solid. So 50% thiamol in ethanol is a strong solvent for sesame oil. Now this solvent system is behaving like hexane, and removal of thiamol and ethanol, there will be traces of thiamol and ethanol. So the traces of hexane have been replaced by traces of thiamol, which is safer. So anyway, so many things are there. So in this way, you can employ solubilizing power of solids for extraction. Those who are interested, they can contact me. I can give the details of all these things. If they want to have some, if they want to carry out some project for extraction using solids, okay, these are the yields, etc. The published paper gives the details of all these things. Now coming to some information for those who want all these things on YouTube. I have made 7 YouTube videos. Eco-friendly lecture series number 1. If you put on the YouTube, on the Google search, you will have this particular video of about 5 to 45 minutes duration. Eco-friendly and economic UV spectrophotometric analysis of poorly water soluble drugs by application of hydrotropy, mixed hydrotropy and mixed solvency concept without the involvement of organic solvent. Okay, so those who are interested for UV analysis, they will see this. Even if you have some doubt or you want to discuss something, I am available to you, whether you are a student or teacher. You can contact me. I can do direction if you want. Eco-friendly lecture series number 2. If you put these words, eco-friendly and economic trithetic analysis of poorly water soluble drugs by application of hydrotropy and mixed solvency concept without the involvement of organic solvent. Eco-friendly lecture series number 3. These all YouTubes are of about 40 to 45 minutes duration. Number 3. Each and every substance, whether gas, liquid, or solid, present in this universe has got solubilizing power, mixed solvency concept. Number 4, eco-friendly and economic analytical techniques for DFC of compounds by application of hydrotropic solvency concept without the involvement of organic solvent. Number 5, eco-friendly and economic analytical techniques for reverse phase HPLC of compounds by application of hydrotropic solvency concept without the involvement of organic solvent. Number 6 is for application of solvency concept to formulate dry powder injection for reconstitution of poorly water soluble. This is particularly for pharmaceutics and for projects. Number 7, application of mixed solvency concept to make innumerable eutectic liquids. Eutectic liquids may act as solvent in vast field of time. This is an art. If you want to learn how can you make innumerable eutectic liquids, you please see this video. And if you have some doubt, please ask me. And these are some information of some books and all that. Now this is important. Thank you. And of course, this important is the WhatsApp number. My WhatsApp number 9406621907. Email ID rkrkmaheshwari@yahoo.co.in. With this, I am finishing my lecture. Now I am going to be present for answering your questions.
Before the query, I want to say that Dr. Satish Sharma, our Honorable President, Society Pesots, has been joined. So kindly invite them for a few words.
Thank you, Dr. Himanshu. So, first of all, I would like to congratulate and compliment particularly Dr. Grendra Gautamji, Dr. Himanshu, and whole team of Pharmaceutical Educational Society for choosing such a wonderful speaker who is a renowned speaker, who is a global speaker, who is an eminent academician and a scientist, researcher par excellence. So we are immensely pleased to have you, Professor Maheshwari Saab, here amongst us. We are really pleased to have you here, and you spared your valuable time. We are really grateful to you, sir. And as far as lecture, your deliberation is concerned, it is really in tune to your level. What is your global level? And I personally also learned so many things. In fact, as you mentioned twice, thrice, that this is an 100 years old concept, hydrotropy, but the way it has been utilized, the way its applications have been utilized and have been brought to the notice of the world community by you, it is really inspiring for all pharma community. So we, on behalf of pesots, I convey sincere thanks, and really we are grateful. And I also compliment all the delegates who have come here and joined this lecture. This is a very important lecture, and I will request all the delegates who are here that they should go into the insights of whatever has been explained by sir in regard to this hydrotropy concept, hydrotropic solubilization. So by using this technique of hydrotropic solubilization, definitely the researchers, scientists will find a solution in regard to developing the new drug entities. We know that most of the new drug entities which are being synthesized, which are coming through combinatorial chemistry or high throughput spring, they are insoluble. So due to insoluble aspect, there is a hindrance in absorption and in increasing hindrance in increasing bioavailability. And if there is poor bioavailability, then obviously the effectiveness of the drug is reduced. So by using this concept of hydrotropy, not only solubilization will be enhanced, but sir has explained the application of this hydrotropic solubilization in different fields by giving beautiful examples of many drugs, ibuprofen, indomethacin, and so many important drugs he has mentioned here, tinidazole and like that, in a beautiful way. So it is eco-friendly. The purpose of new national education policy is to bring about sustainable development. So this is an important step. So I will request through this platform to the fellow young pharmacy professionals, young researchers, to adopt this concept in the research for sustainable development. So I once again thank you, sir. Thank you, everyone. Thank you so much.
Thank you so much, sir, for your blessings and guidance. We are very humbled by your presence. We are very thankful uh, for your presence, for your being here. Continuing, if anyone have any query, we can please put your queries. Sir will be answering for the question and answer session.
Mr. Himanshu, you have a query on the YouTube channel. So regarding that, you can ask the sir.
Yeah, sure, sir. I will be looking and giving the answers, so forwarding to the sir. I think Miss Avnika Tyagi have query. Please, ma'am, please put your question.
Good afternoon, sir.
You're not audible, please, ma'am. Please,
Good afternoon, everyone.
yes, ma'am, please.
Good afternoon, sir. Sir,
Yeah,
I
we
have
can
a
hear you.
question. First of all, thank you for this informative session. Sir, my question is that if we are using aprotic solvents for solubility of a very poorly soluble drug, so for aprotics, by using aprotic solvent, can we use this hydrotropic solubilization technique?
Madam, can you repeat your question, giving some example of appropriate solvent system?
For example, sir, if I'm using a aprotic solvent like uh, dichloromethane, so can we use this hydrotropic solubilization technique if we are using aprotic solvent?
Means, means you want to replace dichloromethane by another safe and economic अपन कहें कि
Yes,
solvent
yes, sir.
system. Of course, you can do.
Yes, sir.
Can I understand your work? I mean, purpose, whether it is extraction
Sir,
or
purpose
synthesis.
is, for example, sir, if we are preparing any formulation like for liposomal formulation or any nanoemulsion in which we are using a phospholipid and we are mixing it using an organic solvent. But for the same also, if we are facing problem in solubility technique, so by using by evaporation or by the other methods for eliminating the aprotic solvent part, can we use this hydrotropic solubilization technique? My question was that only. The technique would be applicable for same to aprotic one also.
Yes, yes, we can do hydrotropic solubilization because hydrotropy is solubility
Okay, sir.
enhancement in aqueous solution only. So we will use mixed solvency
Yes, sir.
concept word. We will use this word, है ना? So we can use the solubilizing power of eutectic liquids. For example, say menthol thymol liquid, thymol
Yes, sir.
camphor liquid, menthol camphor liquid, like these eutectic liquids which can
Yes,
which
sir.
have are lipidic character, and they can be employed to dissolve your drug as well as your you will say these lipids, etc., and you can carry out the work. But only thing will be Dichloromethane can be evaporated out at room temperature in sufficient time, but the removal of thiol, menthol camphor, etc., it takes you may say some more time for its removal, and
Yes, sir.
you will have to heat it at about say 60, 70 degrees centigrade and sufficient
Yes, sir.
duration
This
of
is the
time.
issue.
Then definitely you can employ these eutectic liquids to carry out your work, definitely, because here also in our lab we have carried out a small work, a small practical work using this same concept of eutectic liquid. They can dissolve, means they have replaced dichloromethane, but only thing will be more time and more temperature you will have to give for the removal of these things, definitely.
Thank you so much,
And I
sir.
would like to
Thank
say
you
you
for
one
your.
thing. I would like to say you one thing. Can you discuss afterwards also, so that I can suggest you what other
Surely,
can you
surely,
can
sir,
do.
I will put a call to you and I will
Huh,
ask my query after
okay.
this session.
So are
Thank
you
you for
there
this
in
wonderful session,
Muzaffarnagar
sir.
only? Are you in
Yes, sir.
Muzaffarnagar only in
Yes,
college?
sir. I am in
Okay, okay,
Muzaffarnagar.
okay. Another question? Any other question?
Uh, any other person would like to put a query at the current moment? It's all right. If we are not having any query at this moment, anyone who is facing any problem regarding the topic or after watching the
Muzaffarnagar
YouTube
you.
video, you can still contact the sir. Sir has also provided their contact detail, WhatsApp and email. If anyone watches the video later and have any query regarding this session, please feel free to contact sir. He's very genuine and kind person. He will surely help you throughout the whole process. Moving on, if no one is having query, uh, thank you so much, sir, for being here, for giving such a precious time. It was really a great lecture. We are very honored by your presence. Uh, this is the 327th lecture for sir. He has served so much to the community that no one has ever did. He has done so much work. Like आप खुद देख सकते हैं 300 lectures देना continuously in this field is not an easy task with such a dedication, right? So I would like everyone to please reach out to the sir in case if you have any problem, especially in pharmaceutics. He's a very professional person. He has expertise, discipline in the pharmaceutics. He has been working in this field for more than 30 years, है ना? So with this said, we would like to conclude this session. I would like to request Dr. Neha Tyagi ma'am, UP State Joint Secretary, UP State Branch, Pesots. Please ma'am, give your words of the thanks and please conclude our session.
Thank you so much, Himanshu sir. First, a very warm good afternoon to all. I, Dr. Neha Tyagi, member of this society. First, I would like to thank our eminent speaker, respected Dr. Rajesh Kumar Maheshwari sir, and National President of this society, Professor Dr. Satish Kumar Sharma sir, to give us your precious time and sharing valuable knowledge with us. I am also thankful to our founder secretary, Dr. Veer Kumar Gautam sir, to organize this conference and whole team member of this society and all participants. So I would like to introduce about our society. Actually, it is originated by teachers and students. This society is committed to create strong synergy between pharmacy teachers, students, through which it promotes the education, learning, and research opportunity, as well as our lecture, included our lecture, today's lecture, and among the students, teachers, professionals, and practitioners of pharmacy. By bringing more awareness, also maintain the ethics of pharmacy officials. It learns to see. Join us. We are sharing a link in this group and also subscribe our YouTube channel. Finally, I would like to thank each and every one of you for your support and participation in making this event grand success. So your contribution has have not gone unnoticed. It is of course noticed, and I am also grateful for all you have done. And thank you so much.
Okay.
Okay. अभी के लिए
Thank
बहुत
you,
बहुत
sir.
धन्यवाद.